Good morning. Happy Wednesday, everybody. How you guys doing today? I think we got most everybody here. Yeah, there we go. Oh yeah, looks like I can't spell morning. The rest of you did much better than I did at your spelling. That's good. So today is Wednesday, so we have a couple things today to talk about. The first one here is Chapter 1, our Intro to Computers and Java. And then we'll talk more about GitHub. I just, 1 minute ago, went and created some repos for people who didn't submit yesterday. So if you did submit the form, you should be all set with your repository. I've got 25 of them made. Okay, I see. You gave me your GitHub username in the other spot here. I can do that. I'll make one more here, and then you guys should be all set. If you haven't submitted that form, the Getting to Know You form, see what I did there? Then do that, and on our break, I can go make some more repositories for you in a second. So just give me 1 second to get these here. That's through 26. Just leaving some notes for myself. I have a little script that does this, which is cool. Because why not, right? Okay, so you should get an email saying you've been invited to collaborate, and you can accept that email, and then you'll have access to that repository. So hopefully you'll have that now. If you submitted the form as of, maybe 5 minutes ago now, you should have access to that. Okay. Hey, yeah, thanks for the wishes for a good semester. We're gonna do our best here with remote semester. So I'm excited though. I got for Christmas a dark chocolate coffee beans. They're, dark chocolate covered coffee beans here. So not only do I get to drink my coffee, but I get to eat these good things here. I bet you guys didn't know it was an ASMR stream too. So just don't turn your volume up too loud. I might have a little bit of chewing noise here. I'm sorry. Oh yeah, that's good stuff. No, I did find out one time though, dark chocolate apparently, if you eat too much of it, is not so good on your stomach. Or maybe that in combination with the coffee beans. Or maybe it was a sugar-free one or something. I had a bad experience with a big bag of sugar-free dark chocolate covered coffee beans or espresso beans or something I got from the website. I think it was nuts.com, where you could get all sorts of cool snacks and stuff. Like the almonds and things were good, but anyway, that was good snacks. So we're going to do Intro to Computers in Java. Again, the idea here is I'm pulling out some of the highlights and telling you these are the things that are interesting to know. There's more information here than we actually care about. And not that it's bad information or anything, but just it goes maybe a little deeper than I would have expected for hey, here's what a computer does. And that's okay. It's not a big deal or anything, but just know there's information there, because the quiz you're going to have, I'll post it after class today, will be over anything from Chapter 1 is fair game. So again, it's open book, open notes, no time limit from once you hit start to when you have to submit. Just submit it by the due date. Okay, and then we'll also talk about our first project, which is you doing Hello World, or just slightly more than Hello World. We're going to pretend to have a little conversation. It'll be fine. And then I'll show you how to get that into your GitHub repository that I created for you. We'll go over all those steps again. I'll use the VMware client because it might be a little easier, kind of like a fresh start looking like you guys will run into. But again, you're welcome to do all that on your local computer. And then we do have our SI study session immediately after class. I guess not immediately. You get maybe a 10-minute break to go get some food or some more coffee or something. But starting at noon, we'll have our SI study session. And I think all of our Zoom troubles got worked out there. I think my computer and everyone else's computer, it was a Monday, and it was unhappy dealing with Mondays. So I think we'll be in better shape now. So I bet my lighting here is not great. I should get one of those fancy ring lights or something, but I don't think I actually have to look really nice on camera, so it should be okay. I've got the Snorlax mug today. This thing is awesome. It's huge. Like, here's something as a good size reference. Like, here's a regular size can. It's like it's the regular size, you know, height wise, but like check that out. How much wider that is, which is awesome. And all of you math fans know, right? Because your volume increases exponentially with radius, right? The wider you get, you're not just growing linearly, you're growing exponentially, which is awesome. I found a good joke for you guys. Let's start with the joke, and then we'll get into actually doing some other stuff. Pull this one up here. I thought of you guys when I found this one. So I was like, oh yeah, I gotta get a picture of this. Here we go. So you probably have heard before that imitation is the highest form of flattery. Right? That's a pretty common saying. But it turns out plateaus are the highest form of flattery. All right, it wasn't great, but yeah, I still thought of you guys because I thought it'd be funny. All right, let me get these ones closed out here. And close that one. Okay. All right. So I'm going to open up my Netbeans here. If you have submitted your username to the Getting to Know You form as of 10 minutes ago or earlier, you should have gotten an email inviting you. If you haven't, let me know. We can take a look after break or on break or after class or something. I'll get you guys set up. I did all the ones. I just downloaded that form maybe like 10, 15 minutes ago to get everyone set up. I did it last night, and then I can do it again as we go. Yep, some people are submitting now. That's okay. So I'll get to it. Yeah, sure. Can't hurt to do it again. All right, so this was our Hello World project. This is a nice little starting point. Come on, work with me here. It's not even Monday. Okay, so 2 people. Did anybody get the email? Is it worked for nobody, or it's just not working for some people? So it'll go to whatever email you signed up with. So I don't know whether or not you used your student email address or one of your personal ones or whatnot. Okay, so at least one person got it. That's a good sign. Makes me feel a little bit better. Okay, cool. Thank you guys. Appreciate it. So yeah, if it didn't work for you, let me know or submit again, and I can take a look. It doesn't actually check for typos if in your username, so just double check just the username is right. You can always check to see if your username is right. You can go to github.com and then you just put in the username. So that's how you can check your username to make sure it's right, because this page will come up. Okay, so I can help you with the cloning repository part here. I'll show you that after. So you have to accept the invitation before you'll have access to the repository. I'll show you guys how that works. So yeah, so check your username, make sure that was good, and then we can go from there. And this is a little more awkward, I'm sorry, since I'm not able to be there in person and walk around and sit there, but if we need to, we can set up screen sharing sessions or do whatever to get you up and running. And it's a one-time step, so it should be good once we get through this step. It'll just take just a minute. I did not warm this up enough. It doesn't stay warm like this one, which is sad. Yep, so when you start a new Netbeans project, you want the Java with Ant Java application. Java with Ant, the Maven and Gradle are other build tools and things. They're really cool, but we don't need to worry about that right now. We just want the Java with Ant is our easy one, Java application. You go next. Yep, and then you're going to make sure it's in your GitHub folder. Again, we don't have the folder. Don't worry about it. We'll get to that when we get there. But we can talk about Chapter 1 first. Okay. All right. So I actually want to make sure I get all of that info. Don't need my hide quick actions. I don't know. That's fine. All right. I should be able to keep an eye on chat while we do this too. All right. Oh my goodness. Sorry. My wife texted me, but I don't. Okay. Low on details. That's unfortunate. So you can clone the repository to anywhere. I'll show you that in a minute. We'll talk about chapter 1. We'll take our break. I'll make a couple more GitHub repositories, and then we'll get back into that after break. So support for Java. So it might not know where Java is. It should, best I can recall. I think I had people with Macs previously. I don't think anyone had trouble with it before. Oh no. Okay, apparently I started coffee before I came up here to my office, but I didn't hit the start button. I don't. Did I add water? I'm tired. Okay. Yeah, it should be good. So there's like all these plugin things. It should just work best I know. Like your base IDE is what we need, and then this Java SE. So this is under Tools and Plugins. So if you don't have the Java SE plugin, we can try and activate this one. And it should be okay. Yeah, I'm pretty sure I had people on Macs. Let me know. We can set up a session and take a look at your screen, see if we can see what's going on there. So Ant is just the build process that runs. So when you go to hit run on this thing, you get all sorts of good stuff. And we're about to talk about that in chapter 1. Okay, yeah, so if you installed Java, you should be fine. This is Ant. It does all of this stuff, which is neat, to run behind the scenes. So all these commands we could run by hand, essentially, and again, we'll get to it almost in chapter 1. Okay. Yeah, I'll have to take a look, Abla, or we can try the step one more time here in a minute. But let's talk about chapter 1 first, and then we'll take a break. I'll make sure everyone has repositories, and then we'll go over those steps for cloning again. So I'll make a test account for myself, and you can see what it'll look like. We'll give it a shot. Is that okay? I think that'll work. Okay, so a couple cool things here. This one, I'm worried now because I archive stuff over to YouTube that they're going to block me and Twitch will get upset with me. But there's what's the video? There's a really good YouTube video. It's a little old now, but it's okay. It's like a 5-minute thing and it's fun. Learn to code, I want to say. Yeah, it's code.org, right? Code.org. Yeah, this video here. So I'm not going to run it because I worry about stuff like that, but I can hit share here, and I'll copy this link, and I'll post this one in the Discord for you guys. It's just a 5-minute thing. You can take a look at it after, but they've got some people you may or may not recognize in here. Come on, Discord's updating now. It's just a quick little video, and it talks about coding. This guy, I think people might recognize. Oops. Discord should go on the other screen, shouldn't it? Copy to the other screen. There we go. Okay. Yeah, there's this guy you might recognize in here. There's this guy you might recognize, but again, it's not that important that you know who those people are. But so I'll put that one in our Java 1 class. So usually I would show it just because it's fun, but it's interesting. So one of the reasons we learn to code, right, and they say better than I do, of course, because it's like a professionally produced video or whatever, is that we just interact with computers across every industry in the world now. There's even farming, right? Who's the person named Bill Gates? So like even the farming industry uses computer code for all sorts of things now. If you ever have a chance, you should look at some of the things that John Deere tractors can do. It's ridiculous. Like, there's more software in that tractor than there is in most cars. Probably not our full EV self-driving cars, but the most traditional cars, there's more software. The thing can basically run itself. It's super cool. It's got like built-in GPS, and you could download the map essentially of your field, and you program in how you want things to be planted or whatever, and the thing will like drive itself. Like, you do the speed control on it, but it's super cool. But learning to code, why doing that is really cool. Okay, so more in chapter 1, a little bit about Java. That is the programming language we're going to be using to learn here. There's lots of different programming languages. It's just a programming language is essentially the way in which we talk to a computer and tell the computer what to do. So you can accomplish the same task in pretty much any programming language. You can get the same tasks done. They just have different features, or really the reason we have programming languages is to make it easier for programmers, software developers, software engineers, whatever you want to call yourself, to make computers do things. So Java got started way back in the 1990s. I can say the 90s. You guys know that's 1900, right? C++ is a different class you can take. We offer C++ here at OCC as well. I forget who's teaching it this semester, but I taught one section of it last semester. If you want to take it over the summer, I think Dr. Ball will be teaching both of the sections we offer over the summer. He's a real good guy. And if you're curious, this is what it is. If you go to YouTube, you can look up Dr. Ball. Let's take a peek. I think we can find all of his stuff too. Dr. Ball. Oh, come on. John Ball. There we go. And we can find his channel. And he has, I think he's got his C++ class out here. That's from summer. Oh, wow, that's from a while ago. That's an old one, too. That's data structures. But, yeah, he's got a bunch of stuff out here. Oh, look at that. Does he have a named channel? How did he do that? Okay, that's cool. I'm jealous. I thought I needed 100 subscribers to get a named channel. Can I just put my name in here? Does that work like that? Yep, okay. So it doesn't let me do that, of course. So he's cooler than I am. So yeah, do me a favor, if you can, subscribe to my YouTube channel. If I can get to 100 people, I can get a cool URL with my name in it, like he has. And then maybe I'll feel just as good as he is. So let me post his link here. So he's got some good stuff out there too. And we're going to look at his video later on installing Netbeans, Openjdk, and Javafx. It's slightly old because this was version 11 when he did it, but it's the same steps. So I'll point you guys to that instead of recording a new video, which is cool. So, and he's the department chair, so he gets all the complaints for CIS issues around campus. Okay. Back to Java, chapter 1. So one of the tricky things when we first really started getting into programming is that you had to be very specific to the computer or device that your code was running on. And you'd have to do different things for different devices. And as you can imagine, that'd be a big pain to say, oh, well, everyone got a new computer, you got a new model, I have to go redo all my code. And that's no fun. So Java is meant to be cross-platform in that it could work on different platforms, different devices, even different operating systems. So those of you who have Mac or Linux, if you're not in the Windows club like the rest of us, Java will still work on your computer. They put a lot of time, energy, and effort into making sure that works. Almost all of what we do now are Java applications. There's this cool thing called a Java applet that it would essentially run Java through a website. And best I can tell, that's pretty much dead. I don't think anyone does that anymore because we found out you go to a website and you say, yes, please run code on my computer. is not super secure. It says it's enhanced security, but I think we just ended up having all sorts of trouble with it. Sorry, my phone keeps beeping because people keep submitting forms, which is good. So thank you. Oh, yes, my wife said, not only did I not start the coffee pot, I didn't put the water in and it was smoking. Didn't need the rest of the URL. I'm not sure what you mean, Big E, but all I need is the username, and then I'll be okay. So, all sorts of computer programs you guys might be familiar with. Spotify is a program, right? Microsoft Word is a program. All those things that we run are computer programs. All the apps on your phone are computer programs, right? They're phone apps. Someone had mentioned they're interested in iOS development in Swift or possibly Android. I'm trying to remember now. We do have classes for that as well, which is cool. I think Dr. Baugh teaches the mobile classes, but I don't recall if he teaches the iOS one or not. But we do have classes for mobile development specifically. We used to use Java to do Android applications, but they switched over partly because of all this Oracle nonsense with their licensing to a language variant. They started their own language called Kotlin, which is similar. You guys will be fine picking it up, and you can learn it in the Android class. It's not too tricky, but it's just another way of talking to it. So different things when we start thinking about computer programs. There's a lot more that goes into it than just sticking some code on the screen and hoping it works, typing in stuff here. So most of the time when we run our applications, we don't do it and just like get text output here, right? There's a user interface, and we'll get to that when we get to Javafx at the end of the semester, and that'll be our final project. We're going to do a graphical user interface programs. I can help you out with that later, Ford. I'm sorry you're having trouble with NetBeans. So the things that have to happen when we write our programs, we need to design what the screens are going to look like. Right? Not just is the code going to do the right things, do the right steps, but is it going to look right? Is it going to be user-friendly? There's a whole specialty field of human-computer interaction. The shortcut there for system.out.println is sout, S-O-U-T, and then you hit tab to autocomplete. S-O-U-T and tab. Ooh, you know what? I did forget. I was meaning to. .com. Scott Hanselman is a really cool guy over at Microsoft, puts out all sorts of good stuff, and he had a really cool tool. Here it is. Shortcuts. Where is it here? It will show the shortcuts that you're using. Man, where is it? So I meant to do this here because it's supposed to show you what it looks like. Like as I'm using my shortcuts. Where is it here? Oh boy. It's not extensions. Aha, this one. The hotkeys you're pressing as you press them. All right, there we go. Let me do this. See how all this works. Oh, geez. That's the wrong thing. Oh, boy. There we go. All right. I'm unzipping this here. Let's see if I can make this work. This would be cool, right? All right, let's see. Is this going to work for me? It might work for me. Let's see if I run it. Does it do anything? I want it on Surface Display. Bottom left, sure. Save, keys. It's, I don't know. Let's see if that works. So if I do, aha, look at that. You see a little Control S pop up? I guess I should offset that just a little bit there. That's my problem. Where'd it go? So do a little bottom offset by just a little bit. There, so up a little higher. Can you guys see that? Show up here in the bottom left. And then maybe left offset a little bit so it's not super far in the corner. Nope, that's too far. This is fun, right? This is worth it. Totally worth it. There, look at that. You can see it. Okay, I like that. We will try that. So I gotta remember to use that. So like it'll pop up the shortcuts that I'm doing when I hit Control S for like save. You can see it show up there. That is really cool. I was meaning to do that earlier and I'm glad I thought of it. So other interesting things about programs, other things we have to design. Hopefully it's obvious that you need to make sure it does the math correctly if it's doing any sort of calculations. Right, so we need to understand what is the mathematical process that our program needs to do as it's calculating things. Right, that one we need. We need to think of other external pieces to our software, things like the manual or help, right? We got a little help option built in here, right? How we do things, other forms of documentation. This is not something I'm good at, and I'm not fond of doing, unfortunately, but it is super important that it does get done because we want our software to be usable. We all like to pretend that we're going to build the most easy to use, user-friendly system, and any idiot could figure it out. Unfortunately, that's not always the case, and when you design something and you understand how it works and you've planned it all out, it's going to seem easy to use to you, hopefully. And if it's not easy to use to you, obviously it won't be easy to use to someone else. But just because it's easy for you to use doesn't mean it's easy for someone else. So you have to think about those sorts of things. We have to design them as we're figuring out what our computer program is going to do. In our case, we don't get anything super complex where we're going to have to do any of this stuff. We've got a software engineering class that gets a little deeper into how you do some of these things, and some good processes and procedures for that, which is fun. So most of what we're going to do is just make sure the code works right. But there are other pieces of that that go into writing programs. So one of the fun things, and you're going to learn as we start doing more and more with Java, is you kind of have this flow of how things work here. So what you'll do, oh, look at that, in Word return. I like it. Like document. Nice. Okay, so I need this one down here. All right, so as we go about writing a program, we're not going to do anything super fancy here, but let's see if we could figure out, say, how many semesters it's going to take me to finish my degree. This sort of idea here. So a really good habit you want to get into is figuring out how to solve problems in English first. In that I know what step 1 is, I know what step 2 is. Oh, there's an S there. Step 1, step 2, step 3, because computers are actually really, really dumb. They only do things, and they only do them in the order in which you tell them to do, and they don't know how to skip steps. So we have to be very detailed. There's another good video out there somewhere. Again, would show you in class, but YouTube reasons. It asks kids for, tell me how to make a peanut butter and jelly sandwich. And when you get things like put the peanut butter on the bread, they would take the jar of peanut butter and put it on top of the bag of bread. Like the entire bag of bread. They just put it right on top, because that's what the step said to do. So the idea is we need to get very detailed in our processes to be able to tell the computer what to do. So the step might be, open the bag of bread, take 2 slices of bread out, close the bag of bread, right? Open the peanut butter jar, get a knife, scoop peanut butter out with the knife, that sort of thing. And you could be all sorts of fun and silly with that. And I've done that in person before, just as a fun exercise, where I would follow people's steps. The best part is when you get to eat the sandwich as well. So, but you got to lay out all those steps. So what we're going to do is we're going to lay out these steps logically in English for what we need to do. So in order to figure out how many semesters it's going to take to finish a degree, we need to know some pieces of information, right? We need to know total credits, right? So we need to know how many credits they need to complete it, right? So that's total credits, maybe even like required. I would write the rest of the word required, but I'm running out of space here. So if you know your total credits required, great, that's one step. Then you need to know how many credits they have complete. So credits complete, we need to know. Credits complete. Okay, so that will tell me how many credits they have left to finish. Right, so then we can calculate credits remaining. This is about as good as my handwriting gets, even on a whiteboard in class. So hopefully you can kind of see it and not feel too bad that it's terrible. But there's a reason I type everything. So once we have 2 credits remaining, now we need to figure out how many credits they take per semester. So credits per semester, right? Credits per semester. Those are all good letters there. Okay, so credits per semester. So if you take 12 credits per semester and you have 30 credits remaining, we need to find out how many credits we need, right? So to find that out, now we need to make sure our math is going to be right here. So we're going to take our credits remaining, divide it by credits per semester, and that will equal here, right, our semesters left. Now the problem is, if you have 30 credits remaining and you take 12 per semester, right, that's an ugly number, right? That's what, 15 over 6 is 5 over 2, 5 halves semesters left, right, or 2.5. I can do the math right, don't worry. 2.5. Can you take half a semester? You guys said, I just want to attend the first 7 weeks and I want to be done. That's probably no good here. So what we need to do is we need to take the absolute value. And there's lots of mathematical notations for absolute, or we're going to round up. That's not absolute value. This is why I don't teach math classes. I'm going to round that up. So the common one I've seen is like this little cliff looking things. I don't know, 2.5. You say rounded up versus rounded down, like that direction. I don't know. Any way you want to write it down is fine. Doesn't matter. Or you could just say round up. Whatever makes sense to you. So we just want to make sure we get all the steps down, and I can plan out the steps before I write any code. So a lot of times what you'll do is you'll call this pseudocode. It's kind of like code, but it's not code because I've broken it down step by step by step. So we can even get more steps here. This is just some planning here. And what we've planned is what you'll call an algorithm. It's just a fancy term for these are the steps my computer is going to take. That's my algorithm. Right? This is what you do to accomplish this task. So the programming process is really fun because what we did is we had a problem to solve. So our problem was to figure out how many semesters you have left. So this was the analysis. N-A-L. Analyze. Sure, we'll say we analyzed. We analyzed the problem, and we came up with what our solution is going to be. Okay. The next thing we're going to do is we're going to experiment. We're going to try it. So this is try. We're going to try it out, and we're going to see what happens. Try it means write the code, and test it. I can't emphasize testing enough. You guys should never give me code that you have not run yourself and tried. Right? The idea is that you wrote something and now you need to make sure it does what you expect. Because just because we have the idea of what it should do and we have a nice little algorithm that we planned out doesn't mean it's going to work well. We'll take a look after break. Don't worry about it. We'll figure it out for sure. So always test your code. Make sure it works. Then what happens is, if we need to make any corrections, we can correct it. Right? If we need to, we can redesign. And we do this over and over and over. Oh, hats. Oh, man. Where is my hat? I have one. Might be... Nope. It's back in my bedroom. I have to find someone else for a hat. There we go. I have a nice, lovely Target bag. Give me my hat for now. Yeah, you shouldn't have to resort to the hand command line. That's okay. We can get it set up. Okay, so this is sort of the process, right? Where we analyze the problem first. So once you have a problem, you need to know what your steps are to solve it. Then we're going to try it and test it. And if we find any issues in this test, we're going to correct, redesign, code, test, on and on and on. This just goes in a nice big circle here of analyzing, testing, correcting, redesigning, testing, correcting, redesigning, testing, testing, on and on and on. And some people get really frustrated there, but that's the part where you solve problems, right? Which is cool. So a little bit more about computers specifically. Let's see, can I put another page? Another page. Okay, sure. That'll do. Computers, we generally break their components down into two parts. There's computer hardware, which is all the physical pieces of the computer, and then there's computer software. Right? Software is all the stuff that runs on top of it. And software you can break up a little bit further as well. But the computer itself is lots of physical components. The main one that we say is the brains of the computer is the CPU. Right? That's the central processing unit. That's where all of the calculations and stuff does to make our computer work. We also have memory. Now, memory is our RAM. That's the random access memory. That's our fast storage. That's where the computer can keep things for fast use. It's not long-term storage, and if we lose power, it goes away. So memory is short-term storage. Then you have secondary storage, or let's call storage. That's like your hard drive or other sort of storage devices here. This stuff will stay when the power goes off. It's long-term, but it's much slower to get at than it is the memory. Then you have all sorts of input and output devices, I/O, input and output. So input devices like our keyboard, like my cool little pen here, like a mouse, they're ways that we give data to the computer. And output, things like the monitor that will show us something, it's outputting something. You might even say a printer's an output device. I always felt like that one's a little bit of a stretch, but sure, go for it. And the book has some cool pictures about that. The actual what the CPU does, I'm not as interested in at this level of class. But just know, it only ever does one thing at a time. It just does it really fast. So just because I have lots of programs open doesn't mean they're all actually running at the same time. It's only running one at a time. It's just doing it really, really quickly, taking turns. That's kind of the important thing to know. Our RAM here, our memory, which is really cool, is addressed. So we know where things are stored in memory. So each of them have an address. Just like we've got an address to send physical mail, they all have addresses. Now, for some reason, addresses in memory are done in hexadecimal. And so hexadecimal has the numbers 0 through 9 and the letters A through F, because hex means you get 16, I guess. I don't know why hex means 16, but you get 16 possible digits. So you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. And those mean 0 through 16. Or 0 through 15, actually, I'm sorry. So with our number system, this is 16 to the 0 place. This is 16 to the 1's place. This is 16 to the 2's place. So it's a base 16 notation. So this is the 1's place. This is the 16's place. This is the 256th place, right? 16 squared, versus our usual notation, right? With a base 10 with our numbers here. Again, we're probably never going to need to know this again for this class, but it's just fun. That's the 10 to the 0's place, 10 to the 1's place, 10 to the 2's place, and on and on and on. So you get the 1's place, the 10's place, and the 100's place. Okay? So that's the way that base 16 numbers are counted. RAM, individual things are stored in what we'll call bytes. Now, a byte is fun in that a byte is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So 8 bits make up a byte. A single bit, a bit is base 2. So you have either it is off or it is on. Off or on. So all of these get added up here. So you can be off and on and off and on and off and off and on and on. All of the bits here in the byte are either on or off, and they represent a given value. So that's 1 byte. And that's how we store information. So everything we do in computing is stored in bits. Bits make up a byte, and we store bytes, and we put all of those things together to have information. Now, to figure out the value of this, right, this would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, on and on and on, or 1, 2, 4, 8, 16, 32, 64, 128. So if the value is on, then we add up that value. If it's off, we ignore it. So we get, there's no ones, we get 2, we get an 8, we get a 64, and we get a 128. And we add all those together. So that's 10 plus, I'm busy right now, Jen. 120 plus 60 is 180. 180 plus 10 is 190. Plus 8 plus 4 is 12. So that looks like it's going to be 202 is my guess. So probably 202. And if you're ever confused by it, don't worry. The Windows calculator can do this for you. If you go to programmer mode, you go to binary, and you can punch in a number. Let me shrink that down a little bit so I can actually see here. So in binary, I want you can enter values, or you can go to the binary entering here, and I can enter my value. So I'll flip that one to on, flip that one to on, and flip those ones to on. There we go. So 11001010 is 202 in decimal. That's our regular notation. In hexadecimal, it's CA. All right, this was all really boring and not worthwhile. Sorry, but we'll talk about it. So bits and bytes. So memory then, if you say, hey, I want to store a value, the computer will store some information out at a memory address, and usually you put an X in front of hexadecimal. So you'd say like X6057F2A or some big number. Right? It doesn't, the actual value itself is pretty irrelevant, but that's how we store it here. And the book has some good pictures to make it, hopefully make a little bit more sense. Input, output. Okay. That's about it for hardware. Moving on to software, right? The types of software that we had, another page here, right, are usually broken up into 2 categories. You have operating systems, or OS, and then you have everything else, or apps, sure. Everything else, applications that run on operating systems. So Windows is an operating system, Mac OS is an operating system, iOS is an operating system, Android is an operating system. The operating system's job is to talk to the hardware and run programs on top of it. So the operating system does a whole bunch of cool stuff already, but really your main functionality comes from your apps. Your apps talk to the operating system talks to the hardware. Usually how we go about this sort of thing. Yep. Multitasking, sure. Okay. Yep, we got all that. Yep. Oh yeah, other programming languages. Okay. All right. Elements of a programming language. This one's worthwhile. So each programming language has different sets of rules, or its syntax, right, for what it has to look like in order for it to be able to tell the computer what to do. So there are certain keywords. You'll notice everything here in orange in Netbeans gets highlighted. Those are keywords. They mean specific things to Java specifically. So class and public and static and void, those mean specific things to Java. We have operators. We're not doing a whole lot of operators here yet, but your plus, your minus, division, multiplication, those sorts of things. You have operators. You have that would act on things. We have punctuation, we have these funny semicolons at the end of our lines here. So every command in Java will have a semicolon. Not every line, like this line here does not have a semicolon. There's no semicolon. It's not a command. This here is just the structure of our program. But every command will have a semicolon at the end. And that tells the computer, hey, do this thing. We'll have programmer-defined identifiers. So we haven't done that yet. We'll do that in just a minute. And then other strict syntax rules, other things that we need to have matching so that it's okay with understanding what we want it to do. So if we were to take that program that or the algorithm that we tried to come up with here, and we said, okay, let's see if we could do this sort of thing. So we needed to have an integer value. So int is a keyword in Java. That means I want to store an integer. So we're going to have an integer for total credits required equals 62. And I end with a semicolon. So we're saying this is a command. It's telling Java, hey, go out in memory, give me space to store an integer value. Yeah. I have feelings about formatting, but Java doesn't care about formatting as much, about the white space. This here is one of those programmer-defined identifiers. So I came up with the name for it. This is my name for it. It could be ASDF. Java could care less what we call it, right? Java doesn't matter. I'm going to undo that. So the rule of thumb for programmer-defined identifiers, or what we'll call these variable names, is they should be meaningful. Right? They should tell whoever's looking at your code what it's doing. Okay, so you should always use full words here. Don't skip letters and say rec for required, or even worse, TCR, total credits required. That's terrible. Right? Don't do that, because we want to have it be descriptive here. Right? We want it to show us when we're reading the code what the variable is. So what it comes down to is the code here is really for people, right? For you and for other developers or whoever's grading you, and specifically in the academic world, to see what your code is doing. Okay? The computer doesn't care if it's TCR, if it's A, if it's X, if it's B. The computer could care less, right? It doesn't matter. There we go. We'll undo all those. So you need to pick a name that's meaningful. That's important. And different organizations will have different ideas around how you name things and different conventions. Sure, that's fine. I'm not fond of the convention that says int total credits required. That's just tedious and obnoxious, and I know it's an int because there's an int right here. The nice thing about that is later on in your code, you can use the variable name other places, and you don't have to tell Java it's an int because it knows it is. I'm just not fond of it. Okay, so we've got total credits required. So programmers like to fight over stupid things. I don't know why. Some people say these little curly braces, and that's the shift square brace, like right above the enter key. So they're curly braces here. Some people like them at the end of a line here and then at the bottom. You notice they're matching sets. So when I click on either one of them, Netbeans is highlighting it for me and saying, hey, these are your matching opening and closing braces. Up here, there's matching opening and closing ones. Some people like them at the end of the line. Some people like them on their own line, like that. This is what I usually prefer, but again, I don't care. And what you can do, if you hit Control-Alt-F, Shift-Alt-F, it will format the document for you. And I'm a big fan of letting tools do work for me and not having to do it myself. So any way that it's going to format it for me, I'm happy with. That's the default. I'm a big fan of defaults, because that means it's less work for me to go change it. So I'll usually have them there, and sometimes I'll forget, but I always go and format my document later. And it makes it nice and pretty for me. And I save all the time, that Control-S. Sorry, it's just a habit to save things. Okay, so we've got total credits required, and then we're going to have an int for credits earned, or credits completed already, or something like that. Completed equals, and so this equals is an operator. This is called the assignment operator. We're saying assign the value of 62 to this variable over here. So let's just come up with, we'll just say this is 32 credits completed. Okay? Again, we're just hard coding some values in. So anytime you have a number in here, we'll say it's hard coded, or it's a literal value, because the value is literally in your code. Okay, we didn't ask the user for it. It's in there. It's predefined, ready to go. And then we're going to say we're going to have an int for credits remaining. And now what's cool here is this variable name, this bag is driving me crazy, represents the value. And anytime we use this variable name, Java will go look and see what its value is. So I can say credits remaining is equal to total credits required minus credits completed. And then end it with a semicolon, because this is a command. This is a statement. Okay, so now I've calculated my credits remaining. Then I need an int credits per semester. And we'll say 12, right? That's full-time status is 12. Now, here's where we're going to get into trouble. Because int that we've been using here is for integers. And if you remember back to math class, integers are whole numbers. Right? So if I say, hey, I want an integer semesters remaining equals my credits remaining divided by the credits per semester. Control C for copy, Control V for paste. If you just click once, it puts the cursor there. If you double click on a word, it highlights the whole word. If you triple click real fast, it highlights the entire line. So I'll double click on variables all the time and Control C for copy, because I like to do less work than I need to. The other cool thing you can do in a integrated development environment or an IDE like Netbeans is you can start typing, and it has this cool thing called autocomplete, or IntelliSense, you might have heard of in other languages. And it will give you options for, hey, did you mean this one, this one, this one, or this one? And then you can arrow up and down to find what it is, and then tab will select and complete it. So I can say credits remaining divided by credits per semester. I can do it that way if you don't like to use the mouse around and copy paste, whichever you prefer. Okay? Some people think it's naughty to touch your mouse while you're programming, and I think they're just pompous, and they should get off their high horse. You can be faster eventually, but let's worry about that later when we get there. Okay? So I've got semesters remaining is this divided by that. Now, if we wanted to print that, so we could say like you have, and then we're going to add in here, and it's not really adding, but it's, don't worry about it, just pretend it's adding here. Semester left is left. Okay, and I'll save that. Come on, I just want to shrink this down a little bit. There we go. So when we figured this out, right, we said 62 minus 32 was 30. So 30 divided by 12, right? 30 divided by 12, let me go back to a regular calculator here. 30 divided by 12 is 2.5. Java's going to do a funny thing here, because when we tell it it's an integer and we have a decimal place, it just gets rid of it. We didn't do that rounding step. We need to make sure we're rounding here. So to do the rounding, you know what? I'm just going to go Google it because I don't remember. Java round up. And we'll take a look, and it's the seal function. Look at that. Math.seal. There we go. This is the one I want. Math.seal. So this is some other cool stuff you can do in Java. Don't worry if this doesn't make any sense. I mean, it's like math.seal. Seal for sealing. Here we want the sealing of this calculation here. Oh, and now it's still upset with me because it's saying there's a lossy conversion. Oh, that's okay. So the problem is that we're trying to store something in an integer value, and it's saying it's not an integer value. Java's telling us we're dumb, we did it wrong. So if you want to store something with decimal places, again, we'll get into this more next week. Don't worry too much about it here. But we might want to call it this thing called a double. Don't worry, we'll get to it next semester. Don't stress about it. Now when I run it, I should get, 2.0. When you take an integer and you divide by another integer, you're going to get an integer result. So it turns out ints is not really good for us here. I'm going to just go the lazy route and make all of these doubles. It's not right. We'll get to it next chapter, what the better way to do this is. But for now, I just want to make this work. There we go. So notice we did this cycle multiple times. Where'd my little picture go? Where's my picture? We tried it. We experimented. We coded it. We tested it. Coded and we tested it. We coded and we tested it. And then we had to correct some things. Why? It went down too far. I lost a page. That's weird. That's fine. And we coded and tested and tried, coded and tested and tried till we got it to work. Till we get the right. So 3 semesters left because you can't have half a semester, right? You have to finish the semester. So again, we'll talk more about all this other stuff next chapter, but just the idea is that we're going through that process. We've defined our algorithm, what the steps are. We're going to try it and see what happens. This rounds, it's just magic essentially for right now. Don't worry about it and why I have to put stuff in parentheses. We'll get there. Okay, don't worry too much about it. The one thing Big E had mentioned is Java could care less about white space. I care about white space, but you could do nasty things like put it all on one stupid line or sure, like that. And Java will be fine with that. It will still run because Java could care less. Java's friendly, right? Okay, you can do all sorts of ugly things. And Java says, oh, sure, because it essentially ignores anything that we'll call white space. Anything that's a new line, anything that's a tab is gone. Ugh, semicolons at the beginning of lines. So like add a bunch of these ugly things. Yeah, you can do all sorts of gross things. I don't recommend it here. It's cute, sure, but if I have to read this to grade it, I'm going to be upset with you. Okay, so again, auto format, Alt-Shift-F, it fixes it all, makes it pretty for me. Oops, don't want to get rid of all of that. Get rid of some of those extra lines, and we're good to go. Okay, I should be able to run it, and it looks much prettier. Cool. All right, so that's our statements. What happens behind the scenes here is every time we declare a value, so this is called the declaration. We're telling Java, hey, go tell the operating system you need memory to store this thing. Then the assignment happens, oh, go store 62 there. Go get some memory for this, go store this here. Go get some memory for this, store whatever this calculation comes out to be. Hey, happy Wednesday. It's Wednesday, right? Oh, it's trash day. I forgot to take out my trash cans. That's unfortunate. Okay. Often, what you're going to run into when you are new at programming is you're going to have all sorts of funny errors, and Java will be upset with you. You'll get all these red lines all over the place. Sometimes Netbeans is helpful, and it says, oh, a semicolon is expected. If you have these are called syntax errors, this run button is not going to work for you. So, oop, nope. And it says, oh, there's an error here. It's nice enough usually to tell you where it thinks the error is. It's not always perfect, right? But maybe I'm missing a parenthesis there. Now I get a different error. Now this one says semicolon expected, not a statement, semicolon expected, cannot find symbol, symbol variable seal, location class math. Ugh, that one's not as helpful of an error, right? I put a parenthesis in and it fixes it. So some of these are going to be weird for a while. They're not going to make a lot of sense here. Or maybe we forgot a quote here. And now we get semicolon or parenthesis expected, semicolon expected, unclosed string literal. That one's a little bit more helpful. That's saying you have a string. So a string is just text. That's our fancy word for a bunch of characters. It's a string. And saying unclosed means you started a quote and you didn't close it. So in this case, this one here is closed. What's not closed is this one over here. Okay, because they need to come in pairs. So you'll get all sorts of weird syntax errors, and they're going to be frustrating and obnoxious, and I'm sorry. The more you deal with them, the better you'll get at handling them. It'll just take a little while. But usually it can point you out to the line that you're on that has the problem. It'll get you close. Okay? And the reason that's important is Java is a compiled language, meaning that we have to do this thing called compile the code. So it takes this essentially English version of the code and turns it into not exactly machine code, but machine readable code, something the computer will understand. We actually get an intermediate step here. So when we go and make our code, let's see. I can't just open it, can I? Why is that so annoying? That's okay. I'll just go find it. Okay, so in my documents, in my GitHub folder, CIS 1500. No, winter. There we go. Hello world. So this is the location, right? This is in my GitHub repository. We'll talk more about that after break in just a minute. Looks like we're due for a break. There's all sorts of good stuff. So in src, that's the source. This is the .java file. This is just a text file. You can open this up in like Notepad and look at it and change it and do whatever you want here. That's all fine. Did I open the wrong hello world? Oh, shoot. I'm in the wrong hello world here. I'm in the one from the other class. I will fix that in a minute. Here. Grab all of that, and I want to open the other project. You know what? I'll just start a new project. Let's do that. I'm going to do a Java application, put it in 1500, and we'll call this one Chapter 1 stuff. Oh, just Chapter 1. Okay, and really all I needed actually was this stuff here. I'm just going to grab that little bit of code. Replace that to do. Format it. Okay, so now we're back in business. So now when I go to my GitHub client, let me make sure I go find 1500. It should say, hey, we found some new stuff. 2021. There we go. Or the GitHub client is going to say, hey, I found a bunch of stuff. The gitignore file got changed, which is good. You don't want to add this private stuff. All this XML, MF, XML properties, we don't care. This is all the Netbeans stuff that it needs. What we care about is the chapter1.java. Great, we've got it. And notice it's .java. So that file we could open up. So here's chapter 1 examples, commit, and push. And then if I want to make sure I got it, I go to repository, view on GitHub. And we'll go take a look here. See, here's chapter 1. I can click and open the folder. Chapter 1, chapter1.java. And I can actually see the text of it here in github.com. Right, where I was going with that here is, let me come back. We need chapter 1 example. There's this other, oh, we didn't actually run it. Let me run it. Okay, now we get 3 semesters left. Great, so now we ran it. Now there's a new folder called build. Inside of build, there's this folder called classes. Inside of that, there's chapter 1. There's a new file called chapter1.class. So .class is a specific, it's a Java file that the Java virtual machine will run and use to tell your operating system to go do things. You're going to use the repository that I invited you to over email. The class repository is mine. You don't actually have access to change it. So you're going to be using the private one I created for you that no one else has access to, so no one else can see your code. We'll do that right after break. So if you haven't filled out that getting to know you form, still funny, I'm still proud of my pun. Fill that out. I'll make repositories for you on break. But this class file here, if we could like open this one with like Notepad or something, it's gibberish. You know, there's like occasionally there's English in here, but there's a whole bunch of other stuff that we just have no idea what it is. This is specific to Java here. So you do see there are a couple places where like we'll see, I thought I saw some variable names, but so this is not a text file. We can't go edit this one. And you notice it never even gets added to the Git repository. It gets ignored. Anything in build, the idea is if you can generate it, you don't need to put it in your repository. It's just for the code part. Okay, so we're due for a break. Why don't we come back, say in 10 minutes, say 11:15, and we'll pick it up. Fill out the getting to know you form if you haven't yet. I'll put on some music. You could write it in Notepad for a little while, but eventually you're not going to do everything. So you need a better tool than Notepad. We used to have people do things in Notepad as like, hey, this is how you could do it initially, but it's just a big pain and then I'll bother. So, all right, we'll take a break. We'll come back at 11:15 and pick it up from there. Thanks, guys.
I'd fall asleep to the screaming, sound machine always speaking, left emotional scars. Now I'm 21, a soul of 50 years. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21, a soul of 50 years. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. That's 21. Feels like I'm 50s. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. 21. Oh, that's 21. I'm 21. Oh, just a kid. Oh, I'm doing things I shouldn't know from. Doing things I shouldn't do. At 21. At 21. At 21. Whoa. I'm 21.
I like losing control. I get high when I'm feeling my flow. My mind is focused and I'm ready to go. Ready to go. Nah, I like losing control. I get high when I'm feeling my flow. My mind is focused and I'm ready to go. Ready to go. Nah, nah.
Oh yeah. Are we talking about losing control? I'm gonna show you how we lose control, baby. Watch this. Look, Marty Mark. Watch the way I start up. I've been going hard, but I can go way harder. Every beat I'm on, yeah, you know that I slaughter. And I'm always looking gorgeous, chilling with somebody's daughter. Yeah, she loving me. Say she love the way my chain sitting contemplate. And of course it says my name if you wondering. To let you know who's finna blow. Always win and check the scope. I'm only losing control. Oh.
I like losing control. I get high when I'm feeling my flow. My mind is focused and I'm ready to go. Ready to go. Nah, nah.
Always win and check the scope. I'm only losing control. Oh.
I like losing control.
Welcome to McDonald's. What can I get you today?
Hi, she'll have the quarter pounder with cheese, extra mustard.
No pickles.
And I'll have a 10-piece chicken McNuggets.
And 2 sides of ranch, please.
The we've done this before meal. Get it at McDonald's when you get 2 of your faves for just $6.
Limited time only. Prices and participation may vary. Single item at regular price.
Let's be real. Mopping is a hassle. You have to fill the bucket, pushing a wet, heavy mop around, then cleaning the mop when you're done so it doesn't grow bacteria. A hassle on top of a hassle. Try Swiffer WetJet. With Swiffer WetJet, you start with a fresh pad and cleaning solution every time. And when you're done, you just toss the pad. Swiffer WetJet, the faster, easier, cleaner way to clean your floors.
Allstate now has deeper savings, and deeper savings require deep thoughts and a deep voice, like mine. Save for being a new customer. Save more for adding DriveWise, and save even more for driving safely. Visit allstate.com or click to get a quote. Find out how much you can save today. As someone once said, saving today is money tomorrow. That's deep.
Not available in every state. New customer savings based on early signing discount. DriveWise is an optional feature. Savings vary based on how you buy. Subject to terms and conditions. Allstate Fire and Casualty Insurance Company and affiliates. Northbrook, Illinois.
Alrighty, welcome back. Alright, we have a little bit more to finish up of Chapter 1, not much. We're about done there, and then we'll get into what you need to do to get your GitHub repository set up, and then we'll talk about Project Zero, and then I think we'll be done for the day. And remember, no class on Monday. It's Martin Luther King Jr. Day. There are a couple things the college is doing to celebrate, or some events we're holding. Feel free to take a peek at those, or go out and do some community service, or just take the day off, whatever you guys got to do. So, no class. We'll come back next Wednesday, starting Chapter 2. We'll spend 3 sessions on Chapter 2 before we get going. I will post the quiz for Chapter 1 a little bit later after class. I gotta finish getting that into D2L. You'll have about a week or so. I think it'll be due around next Wednesday or so. So that's just anything from the book is fair game. In addition to anything I've said. So you don't need to have it memorized, right? Just know where to go look it up if you need to. And then we'll have the actual first real project, Project 1, going. So 0 we have to have done just to make sure you got Netbeans installed, you got your Java development kit there, they talk to each other, and you figure out GitHub. At least enough to give me a file. And we'll go from there, okay? So last couple things, I mentioned that we have that class file. So Java is the Java virtual machine. That's when we install the Java runtime environment, or our development kit has it for us as well. That is what talks to specific operating systems. And Oracle now, who owns Java, works hard to make sure that the Java virtual machine runs on all sorts of different devices. whether or not they're Mac or Linux or Windows or even other devices as well. So all sorts of cool devices you can run it on. Yeah, someone had mentioned doing this in Notepad. You're welcome to do it in Notepad for a little while if you want. Eventually you'll run out of capabilities. And just use an IDE. It's what it's made for. It has all sorts of shortcuts for you. It will make your life easier. So Mr. Gaddis goes through some examples of how you could do this by hand if you wanted. So out in the JDK here, let's see. So in OpenDev, where I unzipped this stuff, in the JDK folder, in bin, there's this tool called Javafx. Javafx is the Java compiler that will compile Java code. Once you have a compiled Java code, that's the class file, you can ask the Java application to run that code. It's not very interesting. And that's all sort of what happens in here. Ant takes care of all that stuff for us behind the scenes. It looks like we're not seeing all those details right now, but that's why we like using our IDE, because it does all that stuff for us. Okay. One other thing you might have noticed, this /* and */, these lines here are comments. This is specifically with this syntax and these @ notations. This is Javadoc comments. I will not use these. I will not ask you to use them, but they are useful. It's wonderful. It does really cool auto documentation of your program. I'm going to assume if you can learn how to code, you can learn how to write Javadoc comments. So they are useful. They're wonderful, but I'm never going to ask you to write them. And in fact, most of the time, I will delete those comments. So those are code comments. They are literally ignored by the Java compiler, as if they don't exist. You can have a single line comment with //. No, I'll just leave this here. This is it's a comment and is ignored by the Java compiler. Oh, that's neat. It actually has all my typing stuff. That is fun. So you can add as many comments as you want. Again, I think I told you the story of how I lost points at one time for not having the right comments, and it irritated me, so I will never ask you guys for comments. You're welcome to put them in. What I often see new people do is they'll say this is total credits required, and then they'll name their variable TCR. This is the worst thing you can do. All right? If you have to explain why your variable name or what your variable name is, just use that for the variable name. Okay? Just do that. That static thing isn't going to make a whole lot of sense until we get to talking about classes. So just for now, it's part of the magic, if that's okay. There are reasons, but we'll get to that later on in the semester. So for now, you have to have this. Okay. The programming process, yeah, we did that. Test. The software engineering process is really cool. There's a whole other piece to writing code, the software development lifecycle, designing, writing, testing, debugging, documenting, modifying, maintaining, and even sunsetting or end of life for your software is something to think about when we do software engineering. You'll get there eventually. Right now, we're not quite there yet. We're just writing code. We're not doing a whole engineering process for sorts of things, but we still are going to design it. You should write some pseudocode, right? Sketch out, this is what we're going to do. I don't know if anyone, although it was yesterday, we didn't rate him yesterday. There's a couple cool people on Twitch who write code on Twitch, like for whatever projects they're working on or whatever happens to be. And you'll see a lot of them spend time doing that pseudocode or designing their algorithm, saying this is the steps that need to happen before they write the code. I promise you it's worth your time. Right? If you just jump in and start writing code, it's easy to get lost. You want to understand what you're trying to accomplish first. Yeah, software engineering, yada, yada. Procedures versus object-oriented programming, it really doesn't make a whole lot of sense until we get to writing classes. So the idea with object-oriented programming is that we kind of bundle everything together because it's natural in the way that we talk about things. Like I sit in a chair. A chair is an object. So in object-oriented programming, I could have a chair object, and it would have attributes about itself, like my chair is black, my chair has a cushion on it, my chair can spin, my chair has 5 roller wheels. Those are attributes about the chair, and the things that you do with the chair, I make it go up, I make it go down, I do those sorts of things, like the ways that I interact with it. Object-oriented programming lets you do that in code with objects, but again, it's not going to make a whole lot of sense, so don't worry too much about it. Yeah, I don't know why they throw that in chapter 1. The reason I changed these to doubles is because double tells Java that you're going to have a decimal place, and that makes sure that when I do my 30 divided by 12, I get a decimal place, which can then be rounded up to 3.0. If I left them as integers, Java actually does a bad job at dividing integers in that it throws away the decimal place. So it essentially would round down, which is the opposite of what we want. So once we get to chapter 2, we'll talk more about these types and ways that we can use them and those sorts of rules and whatnot. So just for now, I've made it, we used it so we would have decimal places so the rounding would work for this example. All right, cool. So we got through all of the chapter slides. Fantastic. And again, the slides are out there in D2L for you guys. Oh, someone had asked about the book, right? An ebook. Did you get your question to that answered? Or ask around? You can definitely purchase or rent the book as an ebook. And I think if you do a little bit of creative Googling, you can probably find a PDF somewhere. But I'm definitely going to recommend you pay for it so that Mr. Gaddis gets his credit, because he did put some work into it. But we got all the textbook slides out here for you guys. Right, so those are all out here. And then I started, as I archive these things, I give you the YouTube links here in the archive. They're available as videos on demand or VODs or something like that on Twitch for about 45 days, so it should be fine. And I do like that Twitch has the chat, so you can see what questions people were asking me. But YouTube does some auto captioning, which is nice. So whichever you prefer, I'll try and export them right after class is done and get them published for you guys. So you have them either place, and then they'll at least live longer on YouTube. And if you guys are bored, you can watch last semester and get ahead or something. I don't know, whatever works for you. So let me open up my VMware client, and let's go take a look at this GitHub thing. I think I only saw one person submit to ours, so it must have been the other class doing it. Yeah, F indeed. F. F's in the chat. I deserve that. You know, I saw it typing earlier, too. That stupid thing. It's got to be a setting for that, right? Let's find the setting. Let's fix that so I don't do that. Keys? General? No other options here? Nope. Okay. You could filter it to only show keyboard shortcuts. Yes. That's what I wanted. So how do I do that? Getting started. Home. Karnak. Yes. Okay. I'm disappointed. I don't have more information about keys. Connect. So it's supposed to be logging things. ASDF. Huh. That's depressing. That is depressing. Okay. Anyway, now that I'm stupid. Our system's terrible too. Your passwords are only allowed to be 9 letters long, which is like the worst thing. Okay. Alright, I want to quit and be done. I'm embarrassing. Hotkey it on and off, maybe. Or just open and close it. It was a good idea while it lasted. Let's see. Filter, keys, Karnak. Nope, nothing. Wasn't it called Karnak? Karnak. Guide. Nope, that's not the right Karnak. Innocent. Nope. Oh my goodness. Yeah, there's nothing. Okay. It says you could filter it, right? Like, only show keyboard shortcuts. He doesn't say how. So I'm sad. Sport Jedi? This one better? Can find the mouse cursor? Oh, that's terrible. That's terrible. Yeah, I don't want that. Okay. Forget it. I'm stupid. I give up. And that's fine. What a terrible day. All right. Let's try that again. Oh, I just changed it. Hopefully I remember what it is. I hate changing passwords. Maybe. Maybe. Come on. Just changed it. Work with me here. Come on. Stupid computer. I'm the one that's stupid. I shouldn't be yelling at the computer. That was a little frustrating. And the old password works. That is awful. Awful, awful, awful. All right. Anyway, then. I'm never going to get over that. That is the worst. The worst. Okay. So, on your virtual machine, and don't use Chrome. Chrome is spyware. Spyware is nasty. Chrome is terrible. Hey, Abla, thank you so much for donating your Prime subscription to the Student Scholarship Fund. You, sir, are making me feel better. I appreciate it. For my troubles. Thank you. Come on. Please open. Nothing. Firefox. It's just not my day today. What is going on here? What is going on? Do we have any Firefox processes running? It's going to make me use Chrome, isn't it? Do I have to click the Chrome button? Oh, even Chrome's not working. Edge? Oh, there's Chrome, of course. Okay. Edge. Okay, Edge loaded. I'd rather have Microsoft spying me than Google. That's fine. Yes, I know that. Please open. Yes. Okay. That's fine. Yes. I don't care. Confirm. Yes. Fine. Stop. All right. Anyway, desktop.github.com. Good thing that's turned off so you don't learn my GitHub password. You want to download it. I did the downloading already, and it will install for you here, right? You can download and run it here. Okay? Once it's installed, You're going to open it up and log in. Why can I? Okay, it is opening. It is opening. All right, so actually, let me go get rid of this one here. So repository, show Explorer. I want to do this one. So to remove it here, move to the recycling bin. Yes, trash it, get rid of it. So hopefully you get this Let's Start It screen. Did you guys get here when you first logged in with GitHub? Because a couple of you said you were having some trouble. So what you want is you want to clone repository from internet. And you should only have one in your list. I'm going to have a ton of them because I made them all for you guys. 2021. 2021. Come on. Yep. So here's all yours. I want mine. So did you accept the invite, Abla? Because you have to accept the invite to collaborate, which will like take you to github.com, and you have to click the button that says accept. There's like one last step that you have to accept. Okay. What was your username for GitHub? I'll look and see if I can find it. I wonder if it's just not there. Oh, you can see it. Okay. I might log out of the GitHub client and back in then. Go to File, Options, and then you can sign out and then sign back in. You don't either, Sam? Huh. I might try signing out and back in because they should show up there. I've not had that happen to me before. Yes, 100, 2021. Yeah, you're going to want to clone the one with your username. You don't want mine because you can't make changes to mine. Did you resubmit, Biggie? I sent one a minute ago. The other thing you can try when you go to GitHub on the website here, you should have an option, this big green code button here. You can click and you can say open with desktop. If you say open with desktop, it's going to try and launch GitHub on your computer. And that should take you right to, oh, here I need to go do something. Okay, signing out and back in worked. Sorry, that's terrible. That is really weird. Yeah, if you try maybe launching or logging out and back in from the GitHub client, you should be able to get it eventually there. And it's going to ask you where to put it, this local path. I like Documents GitHub. You guys can put it anywhere you want. It doesn't matter. And we can always go find it later. Okay, you got it working. So then you go to repository, and you can always go show an explorer, and we'll open up the window here. You're going to want this path. So if I copy that path here for when we launch Netbeans. Because our Netbeans project, we're going to need to put inside this folder to make life easy for us. Okay? So if you didn't get it working, let me know. I can set up a screen sharing session with you guys after the fact. We've got all week to get it done. There's not a big rush on it because we're not going to do anything besides like essentially Hello World. Oh, excuse me. Okay, so once we've got that path, then when I go to Netbeans, so I copied it with Control-C. I'm going to go open Netbeans here on the virtual desktop. You probably already have your Netbeans somewhere. Okay, signing out and back in. That's crazy. That is really weird. Sorry for the trouble. I think I can make this a little bit bigger. I don't know if it's going to be upset with me or not. Go just a little larger. Okay. And what we're going to do then, let me pull up our assignments. Got to add a new project. New assignment. Here we go. Yeah, if nothing shows up still, I might have to do a screen sharing session with you. We can take a look. Biggie, what was your GitHub username? Take a look and see if it's there. Definitely did not get created. definitely not there. Don't recall seeing it either. You sure you submitted it to the form? Are you able to, if you're able to see it on the website but not on github.com, try just logging out and back in of the GitHub client. If you can't see it on the website at all, then I probably didn't do something right, or it didn't get submitted. Let me see if I can find it here. I will try and not show this one on the screen with all my passwords. Maybe. Okay, good. It'll open on the other screen. Nope, it did not. All right, that one's fine. It just has usernames. I'm gonna have a terrible day. Not too terrible. Okay, Aiden, I'll make yours. And one other one then. Let's see. Okay. Yeah, I don't have that username listed there, Aiden, so I'm not sure what was getting submitted. That's weird. Let's try this though. Okay, so those two then should be created now. So you should got some email invites for those other two. Yep, once you've done it there, then it should just show full screen. It should be empty. Come back, VM. Okay. Yeah, I'm not sure. I got that username in the form, maybe, or something. Or maybe I don't know. I could have done something wrong. It's very likely. All right, good. Glad you got it. Come on, VM. Wake up. So it should be empty at first, because we didn't put anything in it right away. So what we're going to do is we're going to make our first project is choose some grades. Need to make a new item. New projects. Don't want it to be untitled. No. It's project 0. Oh, okay, it probably takes my same name here. Grades. There we go. New item. This one is 2 points. And we'll have this due next Wednesday, 11:59 p.m. or so. After your invitation to the GitHub repository, your username in it, clone your repository, and create a world application. Netbeans. Code to GitHub and submit to the .java file. Okay, so what you're going to submit is just text, which is just the URL here, and to make a rubric. Yep, I'll show you what it looks like. This is 0. Rubric tool's annoying. Wait, missing. Code. So we're not going to do just hello world. We're going to have the statements and entire project directory is committed to github.com. Is that wrong? Spell it 2 T's? Okay, sure. All right. So this is not just hello world. That means the program tends to have a conversation with the computer. We are hard coding everything in hello world. Hello computer. This is Eric, your name there. Eric, how are you today? I'm having a bad day, computer. I typed my password in where everyone could see it. Okay, just a couple lines here. Does not have to be a super fancy anything there. So, perfect. That's it. All right, so let's do that. So if I can get my virtual machine's not cooperating with me. That's okay. I've got it locally here. I'm going to do the same things here. So I'm going to go to repository, show and explorer to make sure I have the path. And you can click in this little breadcrumb trail area. It'll highlight everything. Control C for copy. Then go over to Netbeans and you want file, new project. So mine's Java with Ant, Java application. Make sure you paste your path in here. So it'll put the project in that directory. This is just project 0. I prefer you name it project 0. I could probably figure it out otherwise, but it's easiest if you just name things the right way like that. Okay, and then all we're going to do in project 0 is pretend to have that silly little conversation with the computer. So S out, hello world, and hello computer. I don't know what else did I say in there. I already forgot. That's the kind of day I'm having. Edit assignment. Come on. This is Eric. Okay, that's right. So I'll say hello computer. This is Eric. And hello Eric. How are you today? And I'll tell it I'm having a bad day. Bad day. I'm dumb. And showed my password. I don't care what you guys type. Just have a couple lines of prints. Anything. As long as it's more than just hello world. Just add a couple other lines and you're okay. Right? And then I'm going to test to make sure it works. So I'm going to hit the run button. I get my output. Great. So the code part is done. Now we need to come back to GitHub. The GitHub client should see a bunch of new stuff. Right? Project 0, all these build, XML, property files. Those are all good. We need to make sure we have the Java file in here. It should all be there. That's great. So this is project 0. You're going to hit commit, and then make sure you push. Commit and push. Once you've done that, you can go to repository, view on GitHub. Now, if you're not logged in, it's going to give you like this sad panda 404 not found kind of thing. Like if I were to actually change the URL, you would get page not found. Okay? So all you have to do is make sure you're logged in. Go log into the GitHub website if it doesn't find it. Because if you committed there, it should be there. Go into the project 0 folder. Go into the source folder, open up the Java file. This URL is what you're going to commit to or give me in Desire to Learn. When you go to D2L, it'll ask you to submit the assignment, and then go back here. I think I can go to my student view. Where's that button for that? I got a button for it, right? I thought I had a button for it. It's not an easy button for it. Anyway, you can go to the assignment. And go fill that one out. Project 0 due. There we go. January 20. Okay, so you can go find it, give it to me there. So commit makes a snapshot of the folder in that point in time. So that's what Git does to track things. It tracks snapshots. So this is what the folder looked like. These are the files, contents at this point in time. Yeah, that's right. I have to go to impersonate. That's bring this in the other window here a minute. Last list. There we go. Find my student account and impersonate you. Look at that. Look at that. I'm Eric Student now. Impersonating my student. Now I can go to assignments or any way you want to find it. And project 0. And all you need to do for your submission here is paste that URL in. And you hit submit. And you are good to go. And you're all set. And you're going to get an email that you submitted it. That's all I need there. Oh, yeah. Wouldn't that be fun? Wouldn't that be funny? Ah, terrible day. A terrible day. And then on my side, it will say, oh, look, someone submitted their assignment. And that's my fake student submitted their assignment. Okay? that's it for Project Zero. Just want to make sure you can get your GitHub repository up and going, you get Netbeans running, you get Java installed, and you can make your Hello World essentially program. I just want, have a silly conversation with the computer. You can make fun of me if you want, laugh about how dumb Eric is for showing us his password. I don't really care. That's all fun. So I don't think we're having an SI session on Martin Luther King Jr. Day. Is that correct, Tim? Because everything's closed that day, or is that one still happening? Yep, so committing to GitHub is not enough. You have to give it to me in D2L to make sure that I can grade it. If you don't submit it to Desire to Learn, I have no idea you turned it in, and I won't know to grade it, and you won't get points, and you'll be sad. So make sure you do both those steps, commit and push. If you can see it on github.com, I'll be able to see it on github.com in the private repository I created for you, and then we're good to go. There also is the being sad is bad. I'll get over it eventually. I'm just rather embarrassed. There's a syllabus quiz that's coming up due that is just asking you to assert that you read the syllabus and you understand our academic integrity policy or academic dishonesty policy. That means cheaters will fail the course. And if you're not sure, please ask, right? But I'm assuming by the time you turn something in, you're asserting it's your own work. And you're saying, I did this. I did this all by myself. If you cite a source, then you're fine. Okay, let's set up a little a screen sharing session after Dimowski. Terrible with names, I apologize. Dimowski, and we can go from there. So I should be able to get you up and running. It's just a couple steps with the downloading and the setup. Once we're done with that, we'll get it done. That's why I do this the first week, right? Because we don't have the lab computers in front of us. I want to make sure all your tools are up and running before we have a real project, a real assignment to do. Okay? So there is tutoring today at noon to 1. And again, if you are able to make it to the tutoring sessions during the week, you'll get an extra point on the quiz for that chapter. So if you can make it this week, you'll get an extra point on your chapter 1 quiz. That'll be posting shortly. And it is 11:50, so I think it's time to be done. It's been fun. I will see you guys next Wednesday. If you are having trouble, reach out, let me know. You guys know how to get a hold of me, and I can help you out with making sure all your tools are set up right. All right, you guys take care. Oh, let's, just for fun here, let's see who all is around. There might be some other fun streamers. Is anybody streaming? The Knowledge Fellowship? Doesn't look like anyone's online right now. Let's see. Let's check one more time. Let's check Twitch. Let's do Twitch Inception. I don't think we can raid Gath. She teaches chemistry. She's really cool. Yeah, she's actually streaming her organic chemistry class, I'm assuming. So you can just go check her out. Let me do this. I'll just do this command here. So, hydrate, thank you. Yeah. There. So we can't officially rate her if you want to go say hi, but she's teaching her chemistry class. You can go learn some stuff for free. She's awesome. All right, I'm going to sign out. You guys take care, and let me know if you have any trouble. I'll be around.